Hi everybody, in this video I'm going to be introducing a method of factorising quadratics, and we're going to be using algebra tiles to do it. When I'm factorising an expression, I'm changing it from an additive expression to a multiplicative expression. For example, this here I have 4 plus 2. Now, how many little squares do I have altogether? Of course, I have 6. At the moment, they are arranged additively. I've got 4 of them, and then I'm adding 2 of them. But I can rearrange these and make them into a multiplying pattern. I could do it like this. I could have, here we go. I have got 2 rows of 3. I've now expressed the same amount multiplicatively. I've said 4 plus 2 is 6, but also 6 is equal to 3 times 2. What we're going to be learning to do is take an expression that looks like this, say x squared plus 3x plus 2, and change it into an algebraic expression where I've got something multiplied by something. We need to have a way to visualize this. I'm going to grab this green square here. Now I'm going to say that this square here has a length of x, so that's a distance of x across there, and it has a width of x too. It's an x by x square. What is its area? Well, x times x is x squared. We're going to have a look at one of these yellow ones now. Now, as you can see, this yellow one also has a length of x, but its width is narrower. Its width is just 1 unit. I've decided that that's what represents 1 unit. What is its area? Well, x times 1 is x. It's a rectangle and its area is x. Next, I have these little blue ones here. Now, each of these blue ones, they have got a length of 1 and a width of 1. You can see that they are the same length as that bit there. Okay, what's their area? 1 times 1 is 1 unit. Now what I'm going to do next is visualize this expression here, x squared plus 3x plus 2, using these algebra tiles. So for x squared, I've got one of these green ones. For 3x, I've got 3 of these yellow ones. And for 2, to represent number 2, I've got 2 of these blue ones. Now what I want to do is represent this expression here, x squared plus 3x plus 2, using these algebra tiles. Now you'll remember that I said I want to turn it into a multiplicative expression. How I do that, I need to arrange all of those squares and rectangles into some kind of big rectangle. Remember what I did when I had 4 plus 2 equals 6, and then I changed it to, well, 3 times 2 is 6. For this one, I had these 4 little squares and these 2 little squares, and for 3 times 2, I arranged them into a rectangle like that. It's a bit messy, but you can see 3 rows of 2. What I need to do now is rearrange my x squared plus 3x plus 2 into a rectangle. Can you see how I could do that? Well, let's put that one there. That one matches on there. I can put that over there. That one there. I think I'll need to rotate this one and match it onto there. Okay, and then where are these 2 little ones going to fit? There and there. Can you see how I've made that those tiles into a rectangle? Now, all I need to do is work out how the length and width of this rectangle. Well, let's think about it. Remember we said that this length along here, what was that little bit? That was the length of x. And what was this little blue length? That was 1, wasn't it? That bit there. So what's this total length along here? Well, it's x plus 1. And how tall is my rectangle? Well, this bit here, what was that length? That length was x, and I've got 1 here and 1 here. So all the way across here, what is that length? It's x plus 2. Now, how do I find the area of a rectangle? I multiply length by width So that's x plus 1 multiplied by x plus 2. Did you know that x plus 1 times x plus 2 has exactly the same value as x squared plus 3x plus 2? It does. We can expand out this using FOIL to check it. X times x is x squared. X times 2 is 2x. 1 times x is 1x or just x. And 1 times 2 is 2. Next, I'm going to simplify that expression. X squared plus how many x's do I have? 2 and 1 is 3, plus 3x plus 2, which is what I started with here. X squared, that's that green area. 3x, I've got an x there, I've got another x here and another one there. And 2 little blue ones over here. Should we try another one? How about this one? X squared plus 5x plus 6. Now we want to factorize it, which means putting it into brackets. It's the opposite of FOIL. What are we going to need? First up, we're going to need an x squared. That's this green one. We're going to need 5 x's, 5 yellow ones. And we're going to need 6 of these little ones. Maybe you could have a think about how you could arrange them into a rectangle. Well, I'm going to start with that one there. Now where will I put these? I might need to rotate them, spin them round. Spin this one round as well. And where would this last one go? Oh, could it go over here? Maybe I'll put it here. Now what we need to do is make a pattern where these little ones are going to fit to fill in the rectangle. You can see, can't you, that all of these 6 little ones are going to fit nicely in here. Okay, so we've arranged x squared plus 5x plus 6 into a rectangle. What do we need to do now? We need to get the length of the sides. That's 1, that's 1, that's 1, and that's x. So all up, what do we have for that length? It is x plus 3. So x plus 3 units that way. And what's its height? Well, we've got x here, we've got 1 and 1. So what's this height here? It is x plus 2. So x squared plus 5x plus 6 is equal to the area of that rectangle, which is x plus 3, lots of x plus 2. And we can check that using FOIL. X plus 3, lots of x plus 2. First, x times x is x squared. Outside, x times 2 is 2x. Inside, 3 times x, 3x. And last, 3 times 2 is 6. So what do we have? X squared plus 5x plus 6. And you can see that it maps on, these terms here map onto exactly what I've got there in the picture. And they're the same as this here. Now I want to show you something, a mistake that some people make when they're trying to do these. They might try and line them up like this and try and say, oh look, that's 4 of them fit along there. No, we don't line them up there. We can only line them up to make at these ones here. The x sides, those long sides have to line up together. So we can line them up like that, and we can also line them up like that, the tall sides there. But what we can't do is line them up kind of in the opposite direction, so like along there. No, that doesn't work. So we just have to make sure that those tall sides match up with each other. Okay, here is another expression here. 2x squared plus 5x plus 2. What do you notice about this one? Do you notice this one here? We've got 2x squared this time. Let's see how we'd go about factorising this expression. First, what do we need? We need 2x squared. That means we need 2 of the green ones. We need 5x, 5 of these rectangles. And we need just 2 little blue ones this time. Okay, how would we go about arranging these ones? Well, let's try it. Let's put those ones together, and then maybe we can have those like that. One of these might need to rotate around. So that one could sit there like that. Maybe that down the side. Does that leave space for two little ones? Yes, it does. So can you see I've made that expression now into a rectangle? Well, how long is our rectangle across? Well, that's 1. That is a length of x, and that is a length of x. So what do we have? 1 plus x plus x. Well, x plus x is 2x. 2x plus 1 is that length along here. And what about this vertical length? Well, that's x, that's 1, and that's 1. So all of this length here is x plus 2. So 2x squared plus 5x plus 2 is equal to 2x plus 1, lots of x plus 2. And why don't we do FOIL to check that? 2x times x, 2x squared. 2x times 2, 4x. 1 times x, 1x, or just x. 1 times 2 is 2. Combine these terms. Plus 5x plus 2. Is that what we started with? Yes, it is. Same as that, same as that. So 2x squared plus 5x plus 2 is equal to 2x plus 1, lots of x plus 2. I have factorised the expression. How about this next one here? 2x squared plus 7x plus 6. Why don't you pause the video and see if you can draw pictures yourself to work out how to factorise this. Or maybe your teacher has given you some algebra tiles that you could manipulate. Press pause. Okay, well, how do we do this? First thing we need to do is think about what we've got. We've got 2x squareds, 7 of these ones here. 1, 2, 3, 4, 5, 6, 7. That's all of my ones there, and 6 of these little ones. Did you work out how you would arrange them? Well, you just muck around with it for a little while, and after a while you kind of get an instinct for how it's going to go. I might put these ones up here, see how much I could stack them. Because I'm wanting there to be space for those 6 little ones. Are they going to fit there? Maybe not. Nope, I don't think it's going to work this way. You see what I've done here? That's not going to work, is it? There's going to be one left over. Well, what do? I'm going to rotate this and then move it down here. And this one, move it down as well. And then these 3 little ones can sit up in here. That's a bit messy, but you'll get the idea. Okay, so now let's just work out the length and width of our rectangle. Well, what have we got here? That's 1, that's 1, that's 1. So overall we have x plus 2 for that length there. And down here we have x, 1, 1, 1. So all of this is 2x plus 3 here. So I should have x plus 2, lots of 2x plus 3, should equal 2x squared plus 7x plus 6. Let's try it. X times 2x is 2x squared. X times 3, 3x. 2 times 2x is 4x. 2 times 3 is 6. 2x squared plus 7x plus 6. Now, I should say, you may have done this the other way around, where you had it like this, 2x plus 3, lots of x plus 2. And that is exactly the same as that. There's no difference. Because remember, say 4 times 3 is the same as 3 times 4, isn't it? With multiplication, it doesn't matter what order you do it in. Here are 3 for you to try. Why don't you try to just draw some pictures and work out how they would factorise? Press pause on the video. Okay, hopefully that went well. For this first one, I'm just going to draw some pictures. We've got x squared, that's one of those. We've got 2x, so 2 yellow ones. I'm going to put one here and one there. Then we've got one little blue one that will go there like that. So what do we have here? X plus 1 up there. Oh look, and x plus 1. This is equal to x plus 1, lots of x plus 1. How about this second one? Well, with this second one, we've got 3 green ones. Now, can I say, if you've got 3, it is a mistake to put them like that. Don't do that. That won't work. So we need to move them and just put them all in a row. I think you can put them in a row or you can put them like in a square, but don't have them kind of in an L shape. Okay, now we've got 4x. How am I going to do that? 4 yellow ones. 1, 2, 3, 4. And where's our little blue one going to go? In the corner there. So what have we got across the top? X plus x plus x. That's going to be 3x plus 1 there, and x plus 1. So this one, 3x plus 1, lots of x plus 1. Or, of course, you could have it the other way around, and that would be fine. What about this last one here? X squared plus 5x plus 4. So that's one of these green ones. 5 of the yellow rectangles. Where am I going to put them? 1, 2, I don't actually know how this is going to work. 3, 4, 5. Now I just have to have 4 somewhere. Now if I put them here in this area here, I'm going to need 6 of them. That's not what I want, is it? That's not going to work. So that can't be it. Let's try again. Rub those out. Well, I've got 5x to put in. How about I go 1, 2, 3, 4 across that way and 1 that way. And then you can see there's just the right amount of space for the 4 ones there. So that's going to go x plus 4 that way and x plus 1 that way. X plus 4, x plus 1. And you can check those by using FOIL. X squared, 1x, 4x, 4 collect like terms, x squared plus 5x plus 4. We are correct. Okay, here's one here that uses bigger numbers. Press pause and have a think about how you do this one. Remember what we've got here? We've got 4 of these ones. We've got 16 of those rectangles and 15 little ones. Okay, how are we going to do it? Well, I'm going to arrange all of these x squared tiles together. I think I'm going to try it with them like this. And then I've got 16 of these yellow ones. That will be 2, 4. Don't really know what I'm doing here. I'm just trying some stuff. 6. I've still got another 10 of them. Well, that will be 8. 10, 12, 14, and 16. Let's see if this will work. 2, 4, 6, 8, 10, 12, 14, 16. Is there room here for 15 ones? Well, 4, 2, no, that makes 16 ones there. I don't want there to be 16. I only want there to be 15. So something's wrong there. How about I take off a bunch of them and we'll start again. Well, how about this way if I have an extra row here? That's going to make 2, 4, 6, 8, 10 there. 10, 11, 12, 13, 14. And will I need, there we are, 16 there. So I've got like that. Will they fit here? 1, 2, 3, 4. That's 3 times 5. Yes, I've got 15 of them there. So what are the dimensions of this? This is 2x there, 2x plus 3. And what have I got here? 2x, and then 1, 2, 3, 4, 5. 2x plus 5. 2x plus 3, lots of 2x plus 5 is equivalent to that. Here are 3 for you to try now. Press pause on the video and see if you can work them all out. Okay, for this first one, I've got x squared, 7x, 1, 2, 3, 4, 5, 6, and 7. And I've got 12 little blue ones. And they all fit in there nicely like that. So that is going to equal x plus 3, lots of x plus 4. Now this one's a little bit fiddly, a lot of options for it, which means it might take a while. 2x, and then we've got 2x squared, and we've got 11x to fit in. So 1, 2, 3, 4. Now I'm bearing in mind that I've only got 5 of these little blue ones, so I might think about them going like this. So that'll require one of those. 2, 4, okay, 6, 8, 10, and 11. Yep, that should work. So how have I done that? That is 2x plus 1 along the bottom, and up the side I've got x plus 1, 2, 3, 4, 5. That expression there is equivalent to that. It has the same value. Final one here, 6x squared plus 13x plus 2. This will take a little while to work it out. So now this is what I'm thinking. I've got 6x squared. I'm going to try and just line them all up like that because I can see I've got 13 x's, and that's a lot. So down the side here, 1, 2, 3, 4, 5, that's 6 down the side there. Let's put another 6 here. That will make it 12. And 13th one along there. And then we just need 2. Now, why did I know to do it like that? Well, a bit of experience, also seeing that I've only got 2 little ones there. So it's to get all of those 13 in, it's probably going to have to be pretty long. So what do I have down the side? 1, 2, 3, 4, 5, 6. That's 6x plus 1 long and x plus 2 wide. And of course you could have had that in the other way. Now hopefully you've been having some success with those. There's nothing wrong using on your exam drawing pictures like that. That's a perfectly valid way of factorising these quadratic expressions. And if you need more practice, probably just go back and do these ones again.